Hello, so in this video we are going to start looking at solving equations. So up until now we've been looking at expressions, stuff like this. So 2x, okay? This is an expression because it doesn't have an equals in. So if we stick an equals in and we might set it equal to some number, so 2x equals 10, it becomes an equation. Equation equals, it's in there. Now when we're solving equations, we're literally finding what we currently don't know. In this case, the unknown is the variable. Like that's the whole point of algebra. We let variables or pronumerals represent the things that we don't currently know. So x. So what we're literally saying here is that we have some unknown value, x, we're timesing it by 2, so we're taking x, we're timesing it by 2, and that gets us to 10. So if we want to solve this, what we're basically finding is the thing which we don't know, in other words, the x. So surely we should be able to work backwards. So we start with 10, work our way backwards, so instead of timesing 2, we should have to do the opposite, which is divide 2, and that gets us back to x. So 10 divided by 2 gives us 5. Now hopefully you've been able to realise that, like x equals 5, just by logic. 2 times some number gives me 10, the only number that works would be 5. But there's going to be times where this doesn't work or the equation is slightly more awkward. So I encourage you to think of it like this. So what we're literally doing here, thinking about this, is that we should divide 2 on both sides. So divide this side by 2 and divide this side by 2, which leaves us with x equals 5, right? Because you divide this by 2, you just get an x, and you divide this by 2, you just get a 5, okay? Let's see it with another example. Let's try 3x equals negative 27. So if we think about this kind of as a chain, what we're literally doing here is we're taking some unknown value, x, we're timesing it by 3, and we get negative 27. So if I work our way backwards, we start at negative 27, we divide by 3, and we should get back to x. So let's think about this. What we're literally doing is having to divide both sides by 3. Divide both sides by 3. We can reduce the equation, so 3x divided by 3 just leaves us with x, and negative 27 divided by 3 gives me negative 9. There's the solution to my equation. It even works with things like this. For example, if I have a, and I put it over 4, and it gives me 6, we've just got to remember, what does the over 4 bit mean? It just means divide 4. Think about the first video that we did. So what I'm literally saying here is I'm taking some value, I'm dividing it by 4, and I end up at 6. So if I work my way backwards then, I should start at 6, I should times both sides by 4, and that gives me a. So I should just times both sides by 4. Times both sides by 4. So on the left-hand side, a divided by 4 times by 4, I'm just left with a. And the right-hand side, 6 times 4 gives me my 24. Okay? It even works with things like this. So for example, let's say we have y take away 3 equals 20. Okay? So what I'm literally saying here as a chain is I'm taking some value, I'm taking away 3, and the result is 20. So logically then, if I work my way backwards, I should start at 20, I should add 3, and that gives me y. So the thing I do to both sides is I have to add 3. So on the left-hand side, y take away 3, add 3, I'm just left with a y. And on the right-hand side, 20, add 3, gives me 23. What about something like this then? Let's try c. If I add 10, and that gives me 40. Well, okay, let's think about this logically in terms of a chain. We start with c, we add 10, that gives me 40. So if I want to work my way backwards, I should start at 40, I should take away 10, and that should get me back to c. Okay, so I just have to take away 10 from both sides. So if I take away 10 from the left-hand side, I'm just left with c. Take away 10 from the right-hand side, I'm just left with 30. By the way, you don't have to write this out every single time. That should kind of be taking place in your head. But certainly, if you can get from this line to this line, and it helps, great. What about something like this then? Let's try, I don't know, 2x plus 6 equals 14. Okay. Well, here we're doing two things, aren't we? We're literally starting with x, then we're timesing it by 2. So we times by 2 first, and then we add 6. So it's kind of writing down the operations of a chain, and that gets me to 14. So logically, if I work my way backwards, I should start with 14, then I should take away 6, then I should divide by 2, and that should get me back to my x. So what did I do first? Well, first things first, I took away 6 from both sides. Let's take away 6 from this side, take away 6 from this side. So let's think, 2x plus 6 take away 6. That's just going to leave me 2x, because the plus 6 and the take away 6 cancel each other out. So I get 2x equals, well, 14 take away 6, remember, is 8. And then what did I do? Well, then I just divided both sides by 2. That's literally what my chain told me to do. So I divide both sides by 2. On the left-hand side, I just end up with an x. On the right-hand side, I just end up with a 4. So the solution to my equation was x equals 4. What about something like this then? Let's try 3x plus 9 equals 10. Okay, so here I think about my chain, so I'm just going to write it out. Take my x, I times it by 3 first, and then I add 9, and I end up at my 10. So if I work my way backwards, I should start with 10, then take away 9, then divide by 3, then I'm back at my x, which is what I'm after. So I'm just doing the opposites all the time. So first things first, I should take away 9 from both sides. So if I take away 9 from the left-hand side, I'm just left with 3x. If I take away 9 from the right-hand side, I am left with 1. Then what should I do? Well, it tells me I should divide by 3. So I'm literally just going to divide 3 on both sides. So on the right-hand side, well, left-hand side, first of all, I'm just left with x. On the right-hand side, I could write it as try and work out numerically what 1 divided by 3 is, like as a decimal, or I could just simply write it as 1 divide 3 like that. That's literally the same thing. You happy? 1 divide 3 is just 1/3. Much easier. What if I get given something like this then? So let's try 5x plus 6 equals 2x minus 5. Okay. Here this is a lot trickier because the x's are split over both sides. So that's easy, just to get the x's on the same side. At the moment, I've got a 2x on that side, a 5x on this side. I just get rid of them by taking away one of each from each side. So for example, I'm just going to take the 2x on the left-hand side, just because I can. It could have equally taken the 5x on this hand side, but it doesn't matter. I'm going to take the 2x on the left-hand side. So to get rid of the positive 2x, remember it's a positive 2x, how do I get rid of it? I should take it away. So I take away 2x from both sides. Now let's think here. If I take away 2x from both sides, are you happy that on the right-hand side, there's no x's at all because the plus 2x and the take away 2x have gone? But I am left with a negative 5, like that. Okay. Now on the left-hand side, obviously I've still got a plus 6, but how many x's have I got? Well, I've got a plus 5x and a minus 2x. Collect together like terms, I end up with 3x. Ah, right. This is just exactly the same as what I was doing before. So it's just 3x plus 6 equals negative 5. Well, first things first, if you think about my chain, I'm not going to write it out, but think about it in your head, I would have to take away 6 from both sides first. You can write out the chain to convince yourself of that. So on the left-hand side, I'm just left with 3x. And on the right-hand side, negative 5, take away 3, gives me negative 11. Okay, and then the next thing I should do in my chain should be to divide both sides by 3. So if I divide both sides by 3, I'm left with x on the left-hand side, and the right-hand side, I could sit there and stress about 11 divided by 3, or negative 11 divided by 3, or I could just write it as negative 11 over 3. It's the same thing, right?